Here we go, Math 1, elimination. So let's talk about how we can eliminate. So remember, the key idea here is that we want to get rid of one of our variables. So we're either going to add or subtract to eliminate one variable. Okay, once we do that, then we can solve for the remaining variable. Once we have one variable, we go back to the start and use that one variable to find the other. Then our answer is as a point on the graph. Okay, remember, the whole idea here is that we're finding two equations, we're finding where they intersect. Where they intersect has an x value and a y value, and that's our answer. Okay, that's the one place that works for both equations. Alright, so let's take a look at number 1. So the first thing you look at is the coefficients. Well, I suppose the very first thing you look at, are they all lined up? Remember how we used to do addition problems like this? Or subtraction problems like that? It's kind of the same idea. So we look and say, are the x's lined up? Yes. The y's lined up? Yes. The equals and the numbers? Yes. So we can either add or subtract. Now, the decision to add or subtract depends on the coefficients. Okay, so look for the same number. 3 and 1, not the same. 5 and 5, the same. So I can eliminate the x's. Well, how am I going to make this become a 0x? And so, if I add 5 and negative 5, will that be 0? Or if I take 5 and subtract a negative 5, would that be 0? Well, minus negative is plus, that would actually be 10. The opposites added together become 0, so we're going to add. It's critical that we know what we're doing, adding or subtracting, because that'll determine what we do for every number. So 5x plus a negative 5x becomes 0x. 3x, or negative 3y plus a negative 1y, would give us a negative 4y. And 29 plus 3 gives us 32. So 0x is worthless. We pretty much eliminate it. Negative 4y, to get y by itself, we divide by negative 4. So we get y equals negative 8. That's half our answer, right? Our answer is a point. So the negative 8 value is for y. So how do we figure out x? Well, we grab one of these, doesn't matter which one, and instead of y, I put in negative 8. Because now I know what y is going to be. So then I can find the x. So that's a plus. So negative 5x plus 8 equals 3. Subtract 8. Get negative 5x equals negative 5. Divide by negative 5. And x equals positive 1. So at the point 1, negative 8, these two equations will be intersecting. Okay? And that's how we deal with elimination. So let's just do some problems. So, do they line up? You can even draw lines to help you see that they're lined up. I've got a 4y and an 8y, not the same. 4 and a 4, they're the same. But a positive and a negative means we're going to add to get them to be 0. So 4x plus a negative 4x, 0x. Negative 4 plus a negative 8, negative 12y. 0 plus negative 12, negative 12. I pretty much eliminate that 0x, so since you can't just eliminate it like that, you can just get rid of it like this. Just rewrite it. Now remember, that minus sticks with the 12. So divide by negative 12, and y equals positive 1. And I take one of these equations, doesn't matter which one, and I'll show you why, and I replace the y with the 1. I could even do the other one, negative 4x minus 8 times 1 equals negative 12. They'll come out to the same thing because this is where the equations are the same. So their x value has to be the same when the y value is 1. So 4x minus 4 equals 0. Add 4. 4x equals positive 4. Divide by 4. And x equals 1. If you didn't believe me, let's check the other one. Negative 8 times 1, negative 8 equals negative 12. Add 8. We get negative 4x equals negative 4. Divide by negative 4. and x equals positive 1. So at the point 1, 1, that's where these two equations are the same. Okay? So, looking at 3. 7 and a negative 3x for x's. 4 and a negative 4y for y's. Doesn't matter if we try to get x or y by itself, but it looks like we can eliminate the 4's by doing addition. So 7 plus a negative 3 is a positive 4x. 4 plus a negative 4 is a 0y. Negative 24 plus 8, negative 16. Now, if you do this part and this isn't 0, you did something wrong. Most likely, you subtracted when you should have added. So that doesn't really do anything, so we get 4x equals negative 16. Divide by 4, and x equals negative 4. There's half our problem. Then I pick one of these equations, and instead of x, I put in the negative 4, and then we simplify. Positive 12 minus 4y equals 8. Subtract 12. We get negative 4y equals negative 4. Divide by negative 4. We've seen a lot of dividing by negative 4, aren't we? Y equals positive 1. So the x value of negative 4, y value of 1 is where those two equations intersect. And if you don't believe me, graph it on Desmos or your graphing calculator. You'll see exactly what I mean. Alright, let's look at number 4 now. Okay, x plus y equals negative 10, 2x minus y. So the x's aren't the same, but the y's are. So if I add the y's, because it's 1y, I would get 1x plus 2x for 3x, positive y plus a negative y, 0y, negative 10 plus a negative 14, negative 24. So 3x equals negative 24, divide by 3, x equals negative 8. Pick one of my equations, insert a negative 8 for x, and then solve for y. So add 8 to both sides, and I get y equals negative 2, because negative 2 plus 8 is negative 2. So my answer, negative 8, negative 2. That's the point where those two intersect. Okay, do the next one. Now notice here on this one, okay, x's, y's, and numbers match up. Now this negative 10x and negative 10x. So now they're not only are they the same number, they're the same sign. So if I go negative 10 plus negative 10, that's actually going to be negative 20. So I can't add. What if I go negative 10 minus negative 10? That becomes plus a positive 10. That gives me 0. So I'm going to actually subtract. Okay. Now, subtraction, and it seems to be a little bit more difficult than addition, because we're more prone to make mistakes. So, negative 10 minus negative 10 would give us 0x. Now, sometimes it's helpful to write out the coefficient, so I'd go negative 6 minus a negative 3, because we have to think of that negative there. That's plus, so it's actually 9y, not 3y. So plus a positive 9y equals 30 minus 30 is 0. 9y equals 0. If we divide by 9, 0 divided by anything is 0. So our y value is 0. And then we take one of these equations, and instead of y, we put in a 0, and we solve. 3 times 0 is 0. Subtracting 0 does nothing. Negative 10x equals 30. Divide by negative 10. And x equals negative 3. So, negative 3, 0 is the solution to this answer. And that made no sense, solution to the answer. It's the solution or the answer to the system of equations. Okay, number 6. Okay, once again, look at my variables, negative x, negative 3, negative 5, so we deal with the x's. We're subtracting again because they're exactly the same. Negative x minus a negative x, that's like plus, so that's 0x. Negative 3y, so negative 3 minus negative 5, that's like plus, so it's actually a positive 2y. Then a negative 11 minus a negative 13, that's like plus, so that becomes a positive 2. So if you're not good at doing this, please use a calculator for this part. I don't want you messing up because you can't calculate. So 2y equals 2. divide by 2, and y equals 1. Take one of our equations. Negative x minus 5 times 1 equals negative 13. So, negative x minus 5 equals negative 13. Add 5 to both sides. Negative x equals negative 13 plus 5 is negative 8. Divide by negative 1 because we can't have a negative x. And x equals a positive 8. So my answer, 1, 8, to where these two equations intersect. Alright, number 7. Okay, now we've got positive 3y and positive 3y. So the only way to get this to be 0 is to subtract again. So 7 minus 8 is negative x. 3 minus 3 is 0y. Negative 20 minus a negative 22. It's like plus, so it'd actually be a positive 2. So negative x equals positive 2. Divide by negative 1. We get x equals negative 2. Take one of my equations, doesn't matter which one. Replace the x with negative 2. And simplify. So negative 14, because 7 times negative 2 is negative 14. Plus 3y equals negative 20. Add 14. We get 3y equals negative 20 plus 14 is negative 6. Divide by 3. We get y equals negative 2 as well. So the point, negative 2, is where those two equations intersect. That's the one point that works for both of them. Okay, last one. Okay, negative 6y and negative 6y, so we're subtracting. Negative 10 minus 3 is actually negative 13, not negative 7. Negative 6 minus negative 6, 0y. 22 minus 9 is 13. Negative 13x equals 13. Divide by negative 13. And x equals negative 1. Take any one of these equations, doesn't matter. Replace the x with negative 1. Then simplify. Negative 3 minus 6y equals 9. Add 3. Negative 6y equals 12. Divide by negative 6. We get y equals negative 2. So the point where these two lines intersect, their one solution is negative 1, negative 2. And there we go with the elimination.